Well, welcome everyone to this session on how to build a brain. My name is Dr. Nicole Sherren, and I'm the Scientific Director of the PALEX Foundation. And I'm going to talk to you today about brain development and what we now know about brain development. So what we're going to talk about are the foundations of lifelong learning and health. And what I'm here to tell you is that we now have decades worth of science on this particular issue. It comes from the neurosciences, it comes from the social sciences, the clinical sciences, as well as from molecular genetics, that all point to the fact that the early years are enormously important, and that early experiences literally get embedded in our brains and in our bodies to affect a lifetime of learning and health, either for good or for ill. That has profound implications for all of the policies and programs that support children and families in this province. So, just how does a brain get built? Well, it's an ongoing process. It begins before birth, and it lasts long into what we used to think of as the adult period. As a matter of fact, your brain doesn't stop maturing until you're about the age of 25. And just like when you're building a house where you have to lay a strong foundation before you frame up the walls and run the wiring and the plumbing, in the same way, a brain needs to lay a strong foundation of the most basic circuits which underlie the most basic neural functions and skills to provide a sturdy base for all of the more complex skills and circuits which are going to build on top of that. Now, what you'll notice in this slide is a number of connections here on the y-axis and age across the bottom, across the x-axis on the bottom. And the takeaway from this slide is that there is a surge in neural connections which occur in the most basic circuits early in life. Those are the sensory pathways, vision, hearing, proprioception. And it's followed by a surge in connection formation in more complex skills, which build on top. These are skills like language, literacy, etc. And that's followed even later in development by a surge in skills and circuits subserving the higher cognitive functions, things like problem solving and creativity and decision making. Now, what you'll notice here is that there's also a drop-off in the number of neural connections which occurs over time. So what does this mean for us in terms of brain development? Does this mean that we're actually regressing, maybe getting a little less smart as we get older? Sometimes it feels that way, but that's not actually what's going on. It's a normal process called pruning. And what you see on this slide is a slice through the cortex of the brain. First at birth, then at 3 years of age, then in the mid-teens at around 14 years of age. And what you'll notice is these dark blobs in each image. Those are the bodies of neurons in the brain. And the long lines and processes that come off of those are the areas where the cells are making connections with other cells. So what you see at about 3 years of age is a very, very dense network of connectivity, whereas by the time we reach our teens, that network is getting less and less dense. It's a normal process called pruning, and it happens in a use it or lose it kind of fashion. So the neural connections which are being used the most are the ones that are going to get very, very strong and remain, and the ones that don't get used very often are going to get pruned away. Now, it's really our genes that are telling our cells when they need to reach out and make connections with each other, but it's our experiences which dictate which connections get strengthened and which connections get pruned away. Now, why is this relevant to you? Well, imagine a child who's growing up in a warm, loving two-parent family. They have access to high-quality child care, safe playground in which they can play, lots of friends, good schools, supportive teachers. This child is going to be exercising a particular skill set that we know is going to be important to their later health and learning development. So they're going to be practicing skills involved in early language and literacy. They're going to be practicing skills involved in developing trusting relationships, in getting along with their peers, in learning to regulate their own emotions and cope with the stresses that they find in their lives. Now imagine a child who's growing up in a very, very different set of environments. A child who's perhaps growing up in a family where there's domestic violence in the home. Perhaps the child is being physically abused or verbally abused. There's no safe playground to play in. They don't have access to a lot of friends. The teachers in the schools are overworked and not supportive of all the kids in the school. That child is going to be practicing a very different set of skills and behaviors. They're potentially going to be practicing the skills involved in aggression and fear. They're certainly not going to be practicing some of the skills that we know are important to them, which are things like forming trusting relationships with others, getting along with their peers, being able to calm their own emotions. So these two children are going to have very, very different outcomes as they grow and develop. And it's that use it or lose it kind of interaction which is strengthening some circuits and pruning some away, which is shaping those outcomes across the lifespan. So I've talked a lot about experiences here, but just what kind of experiences do I really mean? Well, there's only one kind that I'm going to talk to you about today, and those are relational experiences. So human infants are born essentially hardwired for social interaction. What you see on one panel of the slide here is a 2 to 3 week old baby who is mimicking the face of the experimenter. How many of you have ever held a baby in your arms? Everyone in the room, of course. So you know what happens when you start to make faces at that child. They start to mimic your face, your facial expressions. We know that infants are reaching out for that kind of social interaction. What you see on the other panel of the slide here are 3 shapes. One which looks very face-like, one which has all the same features, but they're all mixed up and they no longer look very face-like. And the last one has the same amount of dark shading, but it's in a geometric pattern. This is from a famous experiment by Fantz, and what he did was he showed infants who were 4 days old those 3 images and found that the infants preferred to stare at the face-like shape. So we know that as early as 4 days old, infants can recognize the features of the human face and reach out and prefer those features. So you can think of these relational interactions as kind of like the serve and return between 2 players in a game of tennis. But this time, it's the infant that's serving up a particular interaction, and it's the adult which needs to return it in a developmentally appropriate way. And those serves look different at different developmental ages and stages. So when an infant is very, very young, it could look like mimicking the facial expressions of the adult that they're with. As they get older, they might start babbling and the adult babbles back. As they get even older, they might start walking and pointing at objects. The adult starts naming those objects. What this does is it ramps up the child's enthusiasm for what it is that they're doing and makes them want to do it again. So you can understand how in this way they start to practice some of those really important skills that they're going to need as they develop and as they get into the school system and as they get into the workforce. Now, just like any game of tennis, these kinds of serve and return interactions work best when the 2 players are familiar with each other. So we often think about this serve and return as going on between a child and their trusted caregiver. But it doesn't mean that it's exclusively limited to a child and a trusted caregiver. It just means that it goes on best when the 2 players are familiar. So these serve and return interactions with adults help children build very basic cognitive, social, and emotional skills that they're going to need later in life. These are skills like early language and literacy, skills like getting along with their peers in groups, being able to form relationships, and also being able to control and calm their own emotions and their own reactions to the stresses in their lives. These particular skills are enormously important because they lay the groundwork for another set of skills that we call executive function. Now, I'm sure a lot of you have heard about executive function. It's a catch-all phrase for a whole set of skills. Skills like paying attention, being able to follow rules, set priorities, being able to delay gratification around things that you really want, being able to problem solve and be mentally flexible. So executive function operates in some ways like an air traffic control system in a child's brain. Just like at a busy airport when you've got all of those planes landing and taking off all at the same time, and you need to pay attention and prioritize so that you don't have a crash. In the same way, a child needs to be able to pay attention to the important things that are coming at them in the environment and be able to disengage from the things that are distracting or not important. They need to be able to follow the rules. They need to be able to set priorities so that they don't have crashes in their own mental airspace. So in this way, executive function is one of the key skills which is going to help children succeed in school and later in life. We actually have some pretty good data now from the Nobel Prize-winning economist Jim Heckman, who's shown that it's these soft skills, these executive function skills, which are some of the best predictors of employment success later in life. And I hear from a lot of people in the education system today, how are we supposed to prepare kids for jobs that we don't even know exist yet? Well, thinking about executive function and thinking about how we can gear up executive function, help kids practice this skill, is one great way to do that. Now, executive function is a skill. Again, it can be practiced and strengthened. You can think of some of the games that you used to play as reasonably young children as being good at helping kids practice executive function. Things like Simon Says and Red Light, Green Light, where kids have to pay attention. They have to follow the rules. That helps them gear up this skill very, very early in life. So how does serve and return really work? How does serve and return get embedded in our brains and in our bodies? Well, I've told you one way, which is that those serve and return interactions help to strengthen the neural circuits which underlie really basic cognitive, emotional, and social skills. And those skills are going to be the ones that kids really need a strong foundation in to succeed in school and in the job force. But there's one other way. Serve and return interactions also have an impact on how our genes get expressed. This is some reasonably new work. It's only about 20 years old, and it comes from a very famous Canadian neuroscientist named Michael Meaney at McGill University. He was looking at maternal behavior in rats, and he noticed that there were two naturally occurring types of rat mothers. Those who were very, very attentive to their pups. They licked them and groomed them all the time. If one of them got away from the nest, they would definitely go out and retrieve them, bring them back, keep them warm. And another group of rat mothers who were not bad, they just weren't quite as attentive as the good mothers were. So they didn't lick and groom the pups as often. If one scurried out of the nest, they wouldn't go and retrieve it that quickly. Come back if you're cold, she'd say. You know, I can't be bothered to go and get you. And he noticed that as those rat pups aged and became adults, they were less good at solving mazes, and they were more susceptible to stressful situations. What he did then was look at how the genes in those rat pups were expressed, and he found differences. These differences, we call them epigenetic differences, and all that means is that it's the process whereby essentially like a chemical signature comes on and sits on top of the gene, preventing it from being read. This is a normal developmental process. We have 23,000 genes in every single cell in our bodies, but not all of those cells look the same. We have red blood cells, we have bone cells, we have heart cells, we have white blood cells. And all of these cells have a different complement of genes turned on at any given time. It's how they can have the same genetic material, but look very different in terms of the cell type. And what was really revolutionary about Meaney's work was that he showed that an external experience, such as maternal behavior, had a similar kind of impact on our genes. And the genes specifically that were impacted were genes involved in the stress response and in mood regulation. In the pups from the inattentive mothers, those genes were not expressed in the same way that they were in pups from the highly attentive mothers. So in this way, you can see that those serve and return interactions, particularly the ones that occur very early in life, can set us on a trajectory, not just in terms of the different circuits which get strengthened in our brains, but also in terms of which genes get expressed over the course of our lifetime. Epigenetic changes tend to be permanent. It's not actually adaptive for us to have our bone cells spontaneously turn into red blood cells. In the same way, the epigenetic changes which occur early in development as a result of those maternal interactions and those serve and return experiences also tend to be permanent. But I have one piece of good news. It is not all over by age 3 or by age 6 or by age 8 or by age 10. Our brains continue to develop into the adult period up to about the age of 25. What this means is that we have an enormous window upon which we can intervene and make a difference for children who are struggling. The flip side of that, though, is that we also have a window, a longer window, wherein negative experiences can have a detrimental impact on brain development. So, where do we go from here? How do we get in front of these predictable health problems of tomorrow? Well, the first thing we have to understand is what determines whether a child's outcomes will be good or bad. And what I'm really talking about here is resilience. And the number one thing that I want you to take away from this particular area of the talk is that resilience is a state, it's not a trait. We are not born resilient. But we can build resilience in kids if we know how. And you can think about resilience as kind of like a scale, where you've got positive experiences on one end of the scale and negative experiences on the other. And we want to make sure that we are building up the arm with the positive experiences, making sure we've got lots of positive experiences on that arm, as well as ensuring that we don't have too many negative experiences on the other arm, so that that scale always tips to the positive side, even when there's a few negative experiences on there, because we know that we're not going to be able to protect kids from all of the stresses and negative experiences that they have in their lives. But the other thing to think about is the fulcrum on that scale. You all know that as you move that fulcrum, that tipping point, you can make it either easier or harder to tip the scale in a particular direction. So you can think about that fulcrum as kind of like the genes that we're born with. But remember, our genes are not our fate. We can have an impact on gene expression based on the early experiences that we have. So we want to make sure that we're sliding that fulcrum as much as possible so that it gets easier to tip the scale on the positive end, building up the positive experiences and making sure that we're mitigating the negative experiences and ensuring that we don't get too many on the other scale, or on the other end of the scale. All right, that's it for this talk, How to Build a Brain. I hope you enjoyed yourself. Any questions?
Are there some advantages for negative experiences in the sense that it would create a child having to adapt to that kind of situation or come up with more of a creative kind of problem solving? In other words, we see children in homes that are quite negative. Is there a part of that or some of that that could also be reframed or be looking at as building resiliency?
So I think the important thing to understand is that stress does not do a body good. Right. Negative experiences are damaging no matter what the situation. However, not all negative experiences are the same. If you actually have a negative experience or a toxic stress that occurs in a child's life, if they are potentially supported through that with a caring, supportive adult, no matter who that caring, supportive adult is, what that gives them the opportunity to do is think about learning from that adult coping strategies to deal with that stressor. So not all negative experiences necessarily cause damage, but when a child is not supported by any caring adult, that it typically does.
And then the other thing I'd add to that is that I think it's also important to remember that it's the experience that the child is experiencing, not what we're viewing. So often I think as adults we look at something and we put our, you know, our layer on it, how they're experiencing it, and they may be experiencing it less negatively. Anyway,
Yeah.
I just think sometimes it's their experience that's causing the stress or not stress.
Great comment. Very true. Thank you.